This video is going to be a review of equations of lines and planes. Equations of lines and planes. And then the equation of a line in parametric form. And we can maybe call this parametric or vector form. It's given by R naught plus TV. Again, this is going to be the equation line. Again, this is a point on the line. R naught is a point on the line in vector form. And V is the direction vector of the line. This can often be thought of as the slope of the line. And so we'll do an example. Find the vector and parametric equations of a line that passes through the point 211 and has direction vector to -3. And so solution. Again, now we're going to use this equation up here. And we need a point on the line in vector form. So we'll take this point 211 and we'll make a position vector that directed to that point. And now we have everything else we need. So we'll write the equation online. Again, let me just repeat the equation down here to see exactly what we're doing. And so our equation then is going to be 211 plus t times 2 minus 3 like that. and that's the vector. That's the vector equation of the line. If we want to do the parametric, remember that like this is the x value and this is the y value. So x equal 2 plus 2t, y equal 11 minus 3t. Again, these are the parametric equations. And there you have it. So again, we always need a point on the line, and we need a direction vector that gives you the direction of the line. And if you were to plot that, again, you can kind of think of these as points when you're plotting this. So actually, these are actually position vectors pointing to those points, but we can just sort of think of them as points. It's sort of a practical matter. And so let's plot our equations. And so again, we can make t, if we make t equals 0, that'll mean r will have an x value of 2, which is here, and a y value of 11. And when t is 1, x is going to be 4. When t is 1, y is going to be 8. When t is 2, x is going to be 6. And y is going to be 5. And so on and so forth. Now you could also plotted this by noting that we know the line goes to the point 211, and it has a direction vector of 2 and 3. So if we started at that point 211 and went to the right 2 and down 3, we get that point. To the right 2 and down 3, we get that point, and so on and so forth. And you can plot these points. Make a line that connects them. Get something like that. So now let's also look at the case where, let's say you just have 2 points. So we'll go just a little bit faster through this. And so let's say you have 2 points now. And let's even go to 3 dimensions. So suppose a line passes through the points. Find the equation of the line. Now let me say the vector equation. The equation, let's say vector and parametric and solution. So we're going to need a direction vector, but we have 2 points. Now we can easily find the direction vector by taking one point minus the other. It doesn't matter which order we do them in. So direction vector. Now remember, these are points and we're turning them into vectors. So we'll write it as a vector. So let's say I'll start with this point and subtract the other one. So first coordinate will be 1 minus 2. The second coordinate will be 3 minus a minus 4. The third coordinate is 5 minus 7. And minus 1, 7, minus 2, like that. And now we can make the equation. Well, it doesn't, and remember, we need to use this equation. Where this is a point on the line. Excuse me, this is a point on the line right here. So it doesn't matter what point we use. I'll pick maybe this point here. And if we multiply this out, get something like this. And that's the vector form. And the parametric form. Like that. And again, remember, the parametric form is just taking, remember, this is X, this is Y, and this is Z. And just setting X equal to this coordinate, Y equal to this coordinate, Z equal to this coordinate. And again, in this case, we use this point as our point. You could have easily used this point over here. So that's if you have 2 points, you can do that. And also, suppose you want to make a line parallel to another line. So let's see if we can do that. So suppose, so given a line, and let's say you're given this line Find an equation parallel. Excuse me. Find an equation of a line parallel to this line up here, R, that passes through the point -2, 12, 7. Let's see if we can do this. Now, for two lines to be parallel, they have to have the same slope, so to speak, or the same direction vector. So let's find out what is the direction vector of the given line. So again, we have this right here. Let's see if we can sort of break this line apart and get it into the form that we had previously of a line. So let's see if we can group all the t's together. So let's sort of break this up into two vectors. And let's say we get something like that. So notice what I did here. I kind of broke the t's apart from the constant. So anything that had t's I put over here, constants over here, factor out the t. Now we have the equation of the line we're used to. This is like your R naught, and this is like your V. And again, remember, it goes through this point, but this isn't necessarily the only R naught that'll work, but this is the only direction vector, or well, one of the few direction vectors that'll work. So you can see the direction vector is V, like that. And so now we want our line to be parallel to this line. So we want to have the same direction vector for our new line. So for our new line, and let me just give it a different name. Let me just call it R star. We need a point on the line, and we know this point here. Actually, I wrote it as a vector. I kind of got a little ahead of myself. But so that's a point on the line. And plus t times the direction vector. Again, so this is our point. And remember this, so this is the equation we usually have R naught or direction vector and t. And then so now this is the vector equation of the new line. And we could actually multiply it out a little bit and put it together. And we'll get something like this. Again, this is the vector form. and this parametric form. So that's the equation. These are the equations of in the vector form of a line that passes through this point, and it's parallel to this line. Remember, for it to be parallel, we needed to get a direction vector that was the same. We get that.